In this video, we want to go ahead and talk about how to go ahead and pass pointer variables. So here in this example, you will notice that we declare a variable a, which contains a 5. So there it is. There's the variable a, contains a 5. And so a points to the content, ampersand a will give us the address. Then we go ahead and declare another variable b, and b has the ability to go and hold the address of an int. And so b here has the ability to hold the address of an int, and we grab the address of an int from right there. So here is the address of an int, and we take that address and put it right there. So as you can notice, we actually have a link between these two. Now, at this point, we want to go ahead and find out what happens if we actually were to go ahead and pass this information back and forth through functions. Let me go ahead and give you the following example. So you notice over here, we have a variable that is being assigned the address of this this int variable. So this is the notation that we have. If we were to go ahead and take a look at a function call and a function header, so here's a function call. Let's just imagine for a moment that we want to go ahead and pass func ampersand, or we want to go ahead and pass ampersand a. So ampersand a is 1000, which is what is being passed. So whatever we're passing, we need to go ahead and catch it on the other end. And we need to make sure that we catch it with the proper type of variable. So if we are sending on over 1000, which is the address of an int, we need to have the type of variable that's able to go and hold the address of an int. So what kind of a variable can hold the address of an int? There it is. We can hold the address of an int in this type of variable. So you pass the address of an int and you catch the address of an int. And notice how compatible they are. You will also notice that when you actually make a function call and you have a function header, in essence it is really like an assignment statement. So you notice here is an ampersand a that we have, and then there is what is being assigned to, which appears in the function header. So there's nothing new that is being introduced here. If we know how to go and assign two variables, the way that we actually go and pass that information across functions is exactly the same way. The only thing that we have to keep in mind is that whatever we're sending, we need to make sure that we are catching it in the proper type of variable. Whatever we are assigning, it has to be assigned to the proper type of variable. Whatever is being sent, it has to be sent on over to a variable that's able to go ahead and catch it. So there's no difference. So with that in mind, let's go ahead and take a look at this function call right here. So we're sending on over b. So b is this 1000. And so the question that actually comes up is, well, what is this 1000? Well, this is the content section of b. And the content section of b, it says b can hold the address of an int. So we are holding the address of an int, which of course was this address, which belonged to an int. So that is what is being sent on across. And so over here on this end, we need to be able to go ahead and have a variable that's able to go and hold the address of an int. So what kind of a variable can hold the address of an int? Well, there it is, address of an int. It is this kind of a variable, bcopy, that's able to hold the address of an int. So whatever you're sending, we need to make sure that we have the right type of variable to go ahead and catch it. Let's go ahead and skip the second b here for a moment. Let's go ahead and move on to this one. So ampersand b. In this case, we have a 2000. So we're sending the address of a variable that contains an address, and of course that address is going to go ahead and contain an int. So the 2000 is what is being sent. Notice once again we're looking at the third argument. So I'm sending across the 2000, and I need to go ahead and declare a variable that's able to hold the 2000. So what kind of a variable is this 2000 that we're going to be holding? Well, when you go ahead and look at it, you notice that if I go ahead and put the 2000 inside of here, this means that there is one jump, here is two jumps. So what we have here is a two-jump variable that's able to go and hold that 2000. And you notice that that's what we have. Here we have two jumps that ultimately gets me access to that int. So I send the 2000, I catch the 2000, and this 2000, well, what is it? It is a two jump that will actually get me access to that int. Of course, we know that when we're actually looking at function headers, the name of these variables, this is just a mere formality. You can call it whatever you want. You can actually have it be named the same as what we have in the function call, or they could be different. But this naming that I've chosen hopefully is more clear. It's telling us that we're actually sending on over, in this case, a copy of the 1000. This one right over here, it's saying that we're actually sending the address of this other variable there. Let's go ahead and move on to this one, asterisk B. So asterisk B is what we're sending. So B is right there. Asterisk says, give me the contents of what is sitting in location 1000. So location 1000, its content is 5. So what I'm really sending is that 5. Well, what kind of a variable do I need to go ahead and catch the 5? Well, to catch the 5, a 5 is really nothing but an int. So I'm really just capturing an int. So I just need to go ahead and declare an int variable. So notice the key to this is that whatever you're sending, that's what you have to go ahead and catch on the other end. And so everything has to be compatible. Now, the one item that we have not talked about is the second argument that we have. So this B right here. We can also go ahead and send a variable in what is known as a pass by alias. And so let me explain to you how that works. You notice that we have this B variable right here. And well, really, any time that we're sending any of these other variables, we have to go ahead and catch something on the other end. So when we send something, we need to go ahead and declare a variable, which means that we have to allocate some place in memory to be able to hold whatever is being passed, which is either the 1000, the 2000, or the 5. But in this other scenario, this B that we're looking at, it's not really telling us that we are going to go and send across this 1000. When you go ahead and take a look at this B, and you look over here in the function header, you notice something odd. Usually in the function header, we see either the name of the variable and the type, or an asterisk, but we usually don't see an ampersand. Whenever you see an ampersand, what this is saying is that I don't want to go ahead and create another variable to hold anything. What I want to do is I want to go ahead and just say, all right, you have this B that you're sending on over, and this ampersand says do not create another variable, but I want you to go ahead and take the existing variable that we have, which is this B that we're looking at, that B, and I want you to go ahead and just come up with another name for it for the duration of this function. It's kind of like, let's just say that someone is, their name is William in one context, and when they go home, they would be referred to as Bill. So that would be the same thing. In main, what we have is this variable is referred to as B, but then when we go to this function, we're saying that inside of this function refer to the same variable as B alias, which of course means that whatever changes you make to B alias is really modifying this. It's just another name that we're using inside of this function to get access to this other variable. Notice that once again we don't allocate any additional space. Now the notation looks a little odd. So the only rule that you have to keep in mind when you want to go ahead and not create an additional variable and just come up with a name for the same variable is to go ahead and replicate the original declaration. So you're looking at B right here, which is being sent. Let's go ahead and take a look at its original declaration. It's int asterisk and then B. So what we're going to do is we're going to go ahead and replicate that, and so you notice that we have int and then we have an asterisk, and then we have the name of the variable, and of course we know that these names are formalities. We can call them whatever we want. But the important piece is the int asterisk, which of course is also the int asterisk as it pertains to B, which is this variable right here. So we replicate that declaration. And then right before the variable name, there it is, there's the variable name, which of course is a formality, we go ahead and prefix it with an ampersand. So this ampersand is going to go ahead and say, do not go ahead and create another variable, but rather go ahead and use that same variable, but just use another name. So once again, when we want to go ahead and come up with a variable that has a different name without allocating additional memory, is you go ahead and see what is being sent, which is that B. Take a look at its original declaration, which is an int asterisk. You replicate that int asterisk, there it is, int asterisk, and then right before you identify the variable name, which you of course have an option to call it whatever you want, you go ahead and put an ampersand. And this is really the only place that you would see an ampersand in the function header. We use ampersand in these other places, but these are assignment statements. In the function header, when we use an ampersand, it's referring to as a pass by alias. So this is a little prelude into the world of passing pointers across functions. The important thing to keep in mind is that really when you're passing, it is kind of like an assignment statement. So if you already know how to go and assign two variables, you're in essence doing the same thing when you're calling one function and you're capturing that information in a variable. The only thing that you need to remember is that everything has to be compatible. So if you're sending, let's say, the address of an int, you need to catch the address of an int.